Checkpoint 4. The figure indicates the directions of motion of a sound source and a detector for 6 situations in stationary air. For each situation, is the detected frequency greater than or less than the emitted frequency, or can't we tell without more information about the actual speed? So this point is related with the Doppler effect, what we studied from chapter number 17. So the general formula for the Doppler effect is given by the relation f dash, which is equal to v plus or minus v of d over v plus or minus v of s multiplied by f. Actually, what we have in this rule, f dash is nothing but the frequency detected by the detector. And here the v represent the speed of the sound in the medium, because the speed of the sound in the medium will be vary based on the temperature. And here Vd and Vs refers to the speed of the detector as well as the speed of the source. And here F refers to the sound frequency emitted from the source. So this is our general formula for the Doppler effect. By using this Doppler effect, we have to give the answer of the detected frequency is greater or smaller, or we have to give the answer. If there is no proper information, we have to give the answer as can't we tell without more information. Clear? Actually, we have 8 cases inside this general formula. There are 8 cases. I hope you studied very clear in the theory. So we have 8 cases there. So let's we see here. The source, let's we take, I'm going to draw another diagram. So here we have some source. Let's we take the police car. With some siren, because from the siren the sound waves will be emitted. So this is the police car, and here let's we see is the detector. So here the sound emitted from the police car, let's we consider this is the source and this guy is the detector. Now you can see when this police car will emit the sound, it will emit with some frequency. So here if the police car will coming towards this detector, that means this observer, what frequency he will hear. Or if the police car is going away from this detector, what frequency he will hear. So based on these informations, we have to answer for this 6 situation. So let's we see the first case. What is given here? Source is coming towards the detector. So let's we consider this diagram. This is the source. Here the car is the source. Which car? The police car emitted some sound from the siren. So when the source will be coming towards the detector, and let's we consider the detector is at rest. That is nothing but 0 speed. So when the police car will coming towards the detector, where the detector is at rest, what type of frequency he will hear? He will hear more frequency. That means the frequency detected by the detector will be greater than the frequency from the source. Clear? So this is the answer for the first part. Let's we come for the second part. The source is moving away from the stationary detector. So let's we consider this detector is at rest and this police car is moving to the leftward direction. So when the police car is moving away from the detector, what frequency he will detect? He will detect a low frequency. That means the detector frequency will be less than the emitted frequency from the source. Clear? So that means here the frequency heard by the detector will be less than the frequency of the sound emitted from the source. Clear? Because the source is moving away from the detector, so the detector will hear only low frequency. When you come for the third case, you can see they mention both are moving. So that means this time this detector is not at rest. He is moving this direction, right direction. The car is also moving right direction. But the most important thing here, we don't have proper information because the distances matter. Clear? So we don't know about the distance, whether the distance will be or whether the speed will be greater or the speed will be lesser. We have no idea. So based on this diagram, we can't tell. We can't tell. Why? Because they mention only the direction, but they did not mention about the speed. That's very, very important. So they mention only the direction of these two source and the detector. They are moving in the right direction, but they did not give the proper information. We need more information for giving the answer for this. So whether the detector speed is great, detector frequency is greater, or the source frequency is greater, we cannot be able to tell for this diagram, because the main important thing, the speed of the both detector and the source must be given. But in this diagram, they give both are moving in the right direction. So proper information is not given. So we need more information to answer this question. So based on this information, we cannot be able to give the answer for part C. Now we can come for part D. So when you see this, again the same case. Here, source and the detectors are moving in the left direction. So no proper information because we need more information to answer. So again, we have to give the answer for D part. We can't tell without more information. We can't tell without more information. Let's become for E part. Now you can see the detector is moving this direction. The source is moving in the right direction and the detector is moving left direction. That means when they are going to face each other, the frequency detected by the detector will be greater. The frequency detected by the detector will be greater than the frequency emitted from the source. Clear? Now we have to answer for the F question, which is nothing but the sixth question. The source is moving left direction, the detector is moving right direction. So when he is moving to the right direction, when the police car is moving to the left direction, so what will happen? The frequency detected by the detector will be less. So the frequency detected by the detector is less than the frequency emitted from the source. So this is the answer for this sixth situation. So out of the sixth situation, we cannot able to answer for the third situation, which is C as well as D. Why? Because we need more information for these two situations, because they only mention the direction of the movement. They do not give the speed of the detector. They do not give the speed of the source. Once we know this information, then only we can give the answer for part C and part D. But for remaining four questions, it's very clear. So we gave the answer for the remaining four situations. Clear? That's it. Thank you.